Dear boys, good morning, everybody. Hope all of you are well and staying at home for a long time. Though it becomes monotonous for us, but we have no other choice now. We have to stay at home and we have to continue all of work as well. You are already notified that the shutdown or lockdown period has been extended to 6th August. That means the school will remain closed till the 6th August, and there is very poor chance of get back to school in this time. So we have to wait for that to get back to our classes, but we will continue our process. We will try to follow the online classes, and we will try to make a good preparation for all exams, for the board exams. Boys, we were just discussing on chapter 4 in our review class. In my previous class, I have discussed some topics, important topics related to chapter 4, work, power, and energy. And today I'm just going to discuss some creative type questions. As this is a review class, we are just trying to focus on, mainly we are trying to focus on creative type question, mathematical type question. And for that, in my previous class I had discussion on just math type equation, or the topics related to math. So let's start the class. Today the first question I'm trying to discuss is number 1. Just look at the stem here. An object of 20 kg is kept at a height of 100 meter. The mass of the object is 20 kg, and this is kept at a height of 100 meter from the ground. And regarding this theme, what are the questions here? An object of we will just try to focus on question C and D. Number C, if the object is allowed to fall from highest point, then what will be the velocity at the point just before touching the ground? And number D, at which height the potential energy is equal to the kinetic energy of the stimulus object. Focusing on the stem, I hope you can understand this is a question related to conservation of energy. As we have learned, the to regular form of energy, or mechanical energy, or potential energy and kinetic energy. And as the energy is conserved, so potential energy can be transformed into kinetic energy, and kinetic energy can be transformed into potential energy. And the math is based on that concept of conservation of energy. So first of all, if we want to solve the question number C, if the object is allowed to fall from highest point, then what will be the velocity at the point just before touching the ground? If you just follow the figure here, if we want to make a figure here regarding our stain, here the object is at a 100-meter height from the ground. As the height increases, the potential energy increases at the ground. Just at the ground position, the potential energy is 0 because the height is 0 here. And at the peak point, the kinetic energy is 0, but the potential energy is maximum because the height is maximum. That means whenever the height will be maximum, the potential energy will be maximum. And at this point, highest peak point, the kinetic energy is 0. And when the body is just start to fall from the highest peak again, as it moves towards the ground, its potential energy reduces because the height reduces, and the kinetic energy also increases again. So just before before touching the ground, the total potential energy will convert into kinetic energy. So we can say before touching the ground, ep equals ek, where ep denotes the potential energy and ek denotes the kinetic energy. We know the equation of potential energy is mgh, and the equation of kinetic energy is half mv square. As we are trying to determine the value of the v velocity, what will be the velocity at the point just before touching the ground, let the velocity be v. Then we can write v equals root over twice gh, and by putting the values here from the stem, we can get the value of velocity. V equals 44.27 meter per second. So what is the concept here? The concept here is at first, if the object is thrown upward, with the increase of height, the potential energy increases, and when the object if the object is released, and it just moves towards the ground, then before touching the ground, for example, just if we consider this point, before touching the ground, the whole potential energy here, the whole potential energy will convert into kinetic energy, because the height is decreasing here and velocity is increasing, so the whole potential energy will move into kinetic energy. That's why we are using this equation ep equal ek, and by putting the values here, we can get the value of velocity. Okay, this was our first question, that means question number C. Now just try to focus on D. At which height the potential energy is equal to the kinetic energy? That means we have to determine the exact height where the potential energy is exactly equal to the kinetic energy. We don't know what the height is, so let the height is x. For example, we have assumed that the height is x from the ground, where the potential energy is equals to kinetic energy. So at this point, potential kinetic energy ek equals, we can write up b square, and potential energy ep will be mgh, and instead of mgh we will use here mgx, because the height is now x. So from this equation we can write this this way, half m b square equals b naught square plus twice gs, where s is the displacement. What is the displacement here? If the object is thrown released from here, so we are assuming that this at this height potential energy and kinetic energy is equal, so we have to determine the kinetic energy at this height. So there is a displacement between these 2 points, so the displacement will be for example, as we know, the total height is 100 meter and the distance of this point is x, so difference is here 100 minus x. That means the displacement from peak point is 100 minus x. So we can write here half m, the initial velocity is 0, so twice g 100 minus x, where s is 100 minus x is the displacement. And now put the value of mgx. If we just try to do some calculation here, we will get the value of x. What was x? X was our height, where we have assumed that the initial kinetic energy will be equal to potential energy. That means this is the desired height where the kinetic energy and potential energy is same. So in this way we can determine any kind of height for any kind of measurement of kinetic energy and potential energy. We have used the equation of motion here, v naught square plus, as we know, b square equals v naught square plus twice as. That was our familiar equation, but this is a problem related to height, so we are using the acceleration due to gravity here, and here s is the displacement from the peak point to the desert point. So boys, hope you have understood this thing and the solution related to this thing. And next we will try to focus on another question in this chapter, that means in work, power and energy. Most of the time question comes from conservation of energy and the term related to power and efficiency. Conservation of energy, I hope you have understood the math related to conservation of energy. Then we will try to solve a math related to power and efficiency. Let's start the math, and our stain is a tank having capacity of carrying 1000-liter water situated at roof of a 3-storied building, requires 10 minutes to fill with water. Capacity of pump is 0.5 kilowatt and bottom of the tank is at a height of 10 meters from the ground. So there are so many informations in this tank. Total capacity of water is 1000-liter, and here the time given is 10 minutes, and capacity of pump, the pump that is required to lift the water at tank, the capacity of that pump is 0.5 kilowatt, and the height from of the tank that will be filled by the pump. For example, this is our tank of 1000-liter, and we will fill this tank using a pump. The capacity of that pump is 0.5 kilowatt and the tank is situated 10-meter height from the ground. So our first question is, what is work done by the pump? Whenever the question related to work done comes, sometimes the question comes in this way: what is the work done by the pump? That means the maximum work the pump can do, and that is required here. Sometimes the question comes in this way, that what is the work done by the pump to lift the water? That means that is not the maximum capacity or maximum work done by the pump. If we use the equation of power here, the related to power, what will be the maximum work done? We will try to calculate that in here. So in our question, the power of the pump is given 0.5 kilowatt and the time is given 10 minutes. So using these values, we can just get the maximum work done by the pump will be W equals PT. By putting the values here, we will get the total work done by the pump. The maximum work can be done by the pump is 2 into 10 to the power 5 joule. And this is the first question related to the second stain, and the second question is, find the efficiency of the pump. And as we know, what is the equation or what is the representation of efficiency, we can determine efficiency in terms of power or in terms of energy. Whenever we are using energy, efficiency eta, as we know, it is determined by eta is equals effective output energy divided by given input energy. What is the effective output energy here? The effective output energy is that energy which is required to lift up the water within 10-meter height. So here our the required amount of water is 1000 liter and the height is 10 meter. So to lift up this water at 10 meter height, our required energy will be mgh equals we can get the value 98,000. So in our question number C, what was the work done? That will be that is exactly the given input energy by the pump, that was 3 into 10 to the power 5 joule. So putting the values in here, we get the efficiency is always calculated in percentage. So we get the efficiency 32.67%. Actually we can determine the efficiency in another way. You can just apply any one way, any one equation. If we want to determine the efficiency in terms of power, then the equation will be eta equals output power divided by input power. What is the output power? Output power is the output work, that means for 10-second time the total work done, that will be the output power. And input power is just given in the stem, 0.5 kilowatt. So putting the values, we get the efficiency 32.67%. the answer is same just as the before. The procedure is different. You can just choose any one of the procedure from these tools. So I think using power, that means the second equation is quite easier for our calculation. So in this way we can just determine the efficiency of pump, and if determine power, output power, input power, etc. So this was the math related to the power and efficiency. In today's class I'm going to give some homework for you. Hope all of you will follow the class and do the homework, and will submit the homework in comment box related to this lecture. So just try to note down the homework questions. First one is, a ball of 1 kg is thrown vertically with a certain initial velocity u, and the maximum height of the ball is 100 meter. So you have to find out at first find out the initial velocity of the ball. And second question is, identify a point in between A and C where the kinetic energy is 2/3 of potential energy. This is our first stem. And second question and second stem is, an engine of power 1 kilowatt can lift 100 kg of water at a height of 5 meter in 10 seconds. Number C, determine the amount of work done to raise the water. And number D, if the engine takes 2 seconds more time to raise the same amount of water at same height, what will be the change of efficiency? That means these two questions are related to our discussion of today's two question based on conservation of energy, and another one is related to power and efficiency. So boys, hope you will just do your homework and submit it to comment box, and I will consider it for your SBM marks. So just continue your study, take care, stay safe. Goodbye for today.